In this video, we'll look at question 8 from the 2016 exam.
In this question, we have a circuit driven by a 24-volt power supply, and we have two resistors, a 5-ohm resistor and a variable resistor. And the value of the resistance of this resistor is from 3 to 15. That's the range of values it can take. We are asked to find the maximum power dissipated through the constant resistor as the resistance on the variable resistor is varied. So here's a reminder of two formulas which we might want to use. The power through an electric element is the voltage times current, and voltage, by Ohm's law, is current times resistance. And when you combine the two, we see that power can also be written as the current through that element squared times its resistance. And that's really good for us, because the current through both these elements is going to be the same because they are in series, and the resistance, we know that's just 5 ohms. So first the current, so that's the voltage divided by the equivalent resistance of this part of the circuit, 5 plus RV. And when we substitute that into the formula for the power, so we square it and times it by the resistance 5 ohms, we get an expression for the power, which we now need to maximize. That's not very hard because this term is going to be the biggest when RV takes the smallest possible value. And this is what we get, 24 divided by 5 plus 3, because 3 is the smallest value the variable resistance can take. So that's 24 divided by 8 is 3 squared times 5. 9 times 5 is 45. So we have 45 watt for the maximum resistance. So that's the final answer, and in the exam, that was option D.